Comparative study of greedy KMember clustering and Datafly algorithm performance. Abstract: K-Anonymity becomes one of the privacy-preserving data mining method to protect privacy of data when some data mining techniques are applied on it. Good K-Anonymity methods preserve the data privacy yet can still give a high data utility, which means the data analysis and mining applied on it can still give meaningful results. In this research, two K-Anonymity algorithms, namely the Datafly and Greedy KMember clustering algorithm, are compared through experiments. The experiments include the computation of information loss, the measurement of execution time, the comparison of matching cluster members between the original and anonymized data, and the computation of statistical properties. Based on the results, the Greedy KMember algorithm can describe the original data better and can still represent the attribute categories of the original data. The Datafly algorithm gives lower information loss as the value of K increases, and lower execution times. Keywords: privacy, K-Anonymity, Datafly, Greedy KMember clustering, information loss. Introduction. Data mining is one method to get some information from data, involving several techniques, such as clustering and classification. However, data mining techniques may reveal some private information about the people related to the data. For example, in one, shopper's profile can be determined based on their shopping receipt, by using a classification technique, and in 6 the profile of high school students are obtained by crawling their social media accounts. Because of the needs to analyze data while protecting the privacy-preserving data mining, PPDM, 2 is introduced. PPDM is designed to preserve privacy when data mining is used to analyze data. There are 2 approaches to reach the PPDM goal, namely, cryptographic and anonymization approach. When the cryptographic approach is used, data is encrypted first before it is published. However, when encrypted, data is not easy to be analyzed. It needs to be decrypted first. The other approach is by using the anonymization. Hence, the data is anonymized first, before it is published. This way, data can be analyzed without needing the decryption process. There are several PPDM methods, such as enciphering, K-Anonymity, L-diversity, and T-closeness. In this paper, the focus is on the K-Anonymity methods. K-Anonymity 16 is a method to protect data privacy by developing a database record that cannot be recognized, because there are at least K1 similar records in the database. K-Anonymity involves several algorithms, for examples, Datafly, Incognito, Optimal Lattice, and Greedy KMember clustering algorithm. In this research, 2 K-Anonymity algorithms, namely the Datafly 1516 and Greedy KMember clustering 4 algorithm, are compared through experiments. The experiments include the computation of information loss, the measurement of execution time, the comparison of matching cluster members between the original and anonymized data, and the computation of statistical properties. 2 related works. To prevent private information leaking, a method created to protect privacy by modifying the original information. However, the modification may cause the decrease of the information utility. The information may become inaccurate, and when it is mined, the results are also inaccurate. Privacy-preserving data mining, PPDM, 2 is designed so that the original information modification can still protect private information, yet the information utility can still be maximized. This means, PPDM protects the data privacy, but still maintains the information utility when 3 mining aspects, namely, association, classification, and clustering 11 are applied. The higher the information utility, the better the data mining results. In general, PPDM methods include 2 techniques: erasing or masking part of the information and enciphering the information. The first technique includes K-Anonymity, classification, clustering, association rule, distributed privacy preservation, L-diverse, randomization, taxonomy tree, condensation, and cryptographic 11. The second technique includes cryptographic techniques to prevent the information confidentiality 5. However, these techniques are computationally expensive. Some comparative studies on the anonymization techniques have been done. In 3, the performance of 3 types of anonymization techniques, namely, K-anonymity, T-closeness, and L-diversity, are compared. The research concludes that as the number of attributes grows, the information loss increases. The T-closeness technique gives less information loss compared to the other 2 techniques. In 14, the execution time of 3 anonymization algorithms are compared, namely, Datafly 16, Incognito 8, and Samarati 13 algorithm. Based on this study, as the value of K increases, the execution time increases. Another comparative study is done in 7, in which the performance of the optimal lattice algorithm, OLA, 9 is compared the K-anonymity algorithm. Both algorithms are improved in this study, and after that the information loss of both improved algorithms are compared. The study concludes that the information loss of the K-anonymity algorithm is less than the OLA algorithm. A comparative study to learn the impact of applying K-anonymity algorithms on machine learning results is given in 17. In this study, a K-anonymity algorithm is applied on specific data, and some machine learning techniques, such as logistic regression, and naive Bayes classification, are applied on the results. The study shows that the K-anonymity algorithm does not decrease the classification accuracy significantly. 3. K-anonymity. K-anonymity 16 is a method to protect data privacy by developing a database record that cannot be recognized, because there are at least K1 similar records in the database. A group of K records which are similar is called an equivalence class. The value of K in K-anonymity is used to measure the privacy. As the value K increases, the more difficult to recognize a record in an equivalence class, because the probability to recognize a record is. However, if the value of K is too high, the data utility gets lower since the generalization is high. Based on 3, in general, K-anonymity techniques are classified into 2 groups, namely 1 pass K-means 10 and KMember 4. Whereas, according to 5, there are 2 techniques employed in K-anonymity, namely data generalization and suppression. The generalization technique changes a value with other more general value. The other technique is data suppression, which deletes parts of values or database records. These 2 techniques cause information loss. The higher the information loss, the lower the data utility. Hence, a good K-anonymity method needs to balance the trade-off between the information loss and the data utility. 3 attribute types are used in K-anonymity, namely identifier, quasi-identifier, and sensitive attributes. Identifier is an attribute that can directly identify someone. Usually an identifier is unique for each person, for example, an identity card number. Quasi-identifier is an attribute that can indirectly identify someone, for examples, postcodes, and date of birth. Sensitive attribute is private information, such as an illness and salary. The guidance from 11 is used to decide which attributes are identifier, quasi-identifier, and sensitive attributes. In this research, 2 algorithms are used, namely Datafly and Greedy KMember clustering. Datafly 1516 is one of the first K-anonymity algorithms. It uses the combination of generalization, substitution, and suppression techniques. The generalization technique replaces a value with something less specific but semantically consistent value, and the suppression technique deletes a value. To generalize or suppress data, 2 trees are developed: domain generalization hierarchy and value generalization hierarchy. By using the Datafly algorithm, the data is anonymized according to the level of anonymity set by the user. More detailed description of these 2 algorithms are given in the following subsections. A. Datafly. Datafly algorithm 1516 was first developed to anonymized medical data. The algorithm works by performing generalization, substitution, and suppression, without losing essential information too much. In general, Datafly algorithm consists of the following steps. 1. Develop the frequency table, in which each row contains the number of a unique record appears. 2. Check all rows of the frequency table, if all unique records appear more than or equal k. If yes, go to step 5. If no, go to step 3. 3. Check if the frequency table is ready to be suppressed. If yes, go to step 4. If no, go to step 6. 4. Suppress the table. 5. Return the anonymized table. 6. Generalize the table and return to step 1. These steps are also given in Fig 1. B. Greedy K-Member clustering. The greedy K-Member clustering, GKMC, 4 is a K-Anonymity algorithm which uses the idea of clustering to minimize information loss, so the quality of the data is maintained. With this algorithm, data records which are close to each other are put in the same group. Each group contains at least k records. By clustering similar records first, the generalization becomes minimized. The overview of GKMC algorithm steps are given as follows. 1. Develop clusters where each cluster contains one record or tuple. 2. Add tuples to nearest clusters, until each cluster contains k tuples. The distance between a tuple and a cluster is obtained by computing the information loss. 3. Check if the number of tuples that do not belong to any clusters is less than k. If yes, go to step 4. If no, go to step 1. 4. Anonymized the quasi-identifier of each cluster. 5. Return the anonymized table. These steps are also described in Fig 2. A close-up of a sign. Description automatically generated. Fig 1. Steps in Datafly algorithm. 4 experiments. In this experiment, the adult database from UCI machine learning repository is used. The adult database contains data of adult people such as age, occupation, level of education, and salary. The database consists of 48,842 records and 15 attributes. For these experiments only 1,000 records are used, which are chosen randomly from all records. The attributes used in the experiments are age, work class, education, marital status, occupation, relationship, sex, race, hours per week, native country, and salary. The age and working hour attributes are numerical attributes, while the rests are categorical attributes. The salary attribute is used as a sensitive attribute when anonymizing data. The remaining attributes are used as quasi-identifier. The number of each attribute categories is given in Table I. For example, the number of categories of sex is 2, namely male and female. There are 3 experiments conducted. The first, second, and third experiment uses all attributes, only numerical attributes, and only categorical attributes, respectively. For each experiment, different values of k are used, namely, 20, 30, 40, 50, 60, 70, 80, 90, and 100. On each experiment, the following things are observed. The information loss as the value of k increases. The execution time as the value of k increases. The execution time is measured to determine which algorithm is better to be applied in a big data environment. The statistical properties of the anonymized data, such as the number of attribute categories, and the mode of each attribute. The number of matching tuples between the anonymized and original data tables when the records are clustered. This experiment is done to investigate the impact of K-Anonymity algorithms on data mining technique results. The information loss is calculated by using the formula as given in 4. The information loss in this paper is the sum of information loss of each GKMC cluster. Since there is no cluster in the Datafly algorithm, it is assumed that a cluster is represented by a frequency row. A frequency row is a group of records having the same quasi-identifier values. To conduct the experiments, a software implementing the Datafly and GKMC algorithm is developed. The software performs the anonymization based on the algorithm chosen and the input data. The software also saves the execution time and computes the information loss. The results are saved to a file, to be analyzed further. The description of this software is given in Fig 3. Timeline. Description automatically generated. The statistical properties are computed based on the anonymized data, by using the Microsoft Excel software. The clustering is done by using Weka, also based on the anonymized data resulted. V. Results and analysis. The experiment results are given in the following subsections. A. Information loss. Table 2 and Table 3 shows some examples of the anonymization results by using the Datafly and GKMC algorithm, respectively, when all attributes are included, and with k equals 20. Table 2 shows that, with Datafly algorithm, more records are generalized, compared to those on Table 3. This is because, with the GKMC algorithm, records are clustered first, so the generalization can be minimized. As shown in Fig 4, when all attributes are used, as the value of k increases, the information loss of the anonymization results obtained by using the Datafly algorithm decreases. The opposite happens when the GKMC algorithm is used, because as the cluster size grows, more generalization happens, hence the increase of the information loss. When the value of k is low, 20 to 30, the information loss of the GKMC algorithm is lower than those of the Datafly algorithm. The GKMC algorithm makes cluster of size k, so the cluster can have members that are outliers, hence causing more generalization. Other than that, the Datafly algorithm deletes records that cannot satisfy the K-anonymity requirements, which yields a better information loss as the value of k increases. A close-up of a map. Description automatically generated. In general, the same information loss results obtained when only numerical attributes are used, as can be seen in Fig 5. However, the information loss is a lot lower, compared to when all attributes are used. When the GKMC algorithm is used, the increase of the information loss is almost linear. The GKMC algorithm performs better when the value of k is low, 20 to 50. As the value of k increases, the Datafly algorithm performs better. Table V shows some examples of the anonymization results with k equals 20, when the GKMC algorithm is used, and with only categorical attributes included. A close-up of a map. Description automatically generated. A close-up of a map. Description automatically generated. B. Execution time. The execution time of both algorithms are measured. The measurement is conducted by using a computer with Intel, R, Core, trademark, i7-4720HQ at 2.6 GHz DAN 4 GB RAM. The execution time of both algorithm as the value of k increases is given in Fig 7. The Datafly algorithm requires less time than the GKMC algorithm to perform the anonymization. This is because the complexity of the GKMC algorithm is higher than the Datafly algorithm. A close-up of a map. Description automatically generated. Fig 7. The execution time when all attributes are used. The same results shown when only numerical or categorical attributes are used. The Datafly algorithm requires less time to perform the anonymization, compared to the GKMC algorithm. One factor that influences the execution time is the number of attributes included. When more attributes are included, more execution time is needed. See Fig 8. A close-up of a map. Description automatically generated. Fig 8. Execution time when a. Only numerical and b. Only categorical attributes are used. See statistical properties. Based on the previous experiments regarding the information loss, the following values of k are used to compute some statistical properties of the anonymized data. The values of k used for the next experiment are k equals 40, k equals 50, and k equals 30, when all attributes, only numerical attributes, and only categorical attributes are included, respectively. The chosen values give almost the same information loss for each of the three experiments previously described. The first computation done in this part is determining mode of each attributes of the original and anonymized data, when all attributes are included in the anonymization process. The results are given in Table 6. Based on the table, the GKMC algorithm gives matching results on 5 out of 11 attributes, namely work class, marital status, relationship, hours per week, and class. Whereas the Datafly algorithm only gives 4 matching results. In this case, the GKMC algorithm performs better. The number of categories for each attributes of anonymized data resulted from the Datafly and GKMC algorithm are also computed. The results are given in Table 7, respectively. Table 7 shows that the GKMC algorithm in general preserves more attributes categories compared to the Datafly algorithm. The number of categories for each attribute of the original data is given on error. Reference source not found. For example, for the work class attributes, the Datafly algorithm suppresses all the categories, while the GKMC algorithm still preserves 2 out of 7 categories. This means, the GKMC algorithm can describe the original data better. The second computation of mode is done to the original and anonymized data when only numerical and only categorical attributes used. The results are given in Table 8 and Table 9. When only numerical attributes are used, the Datafly works better than the GKMC algorithm. All results match the original data results. When only categorical attributes are used, the GKMC works better than the Datafly algorithm since it gives 4 out of 9 results matched to the original data results. The number of each categories for each attribute is also computed on the original and anonymized data, when only numerical and only categorical attributes are included. See Table X and Table 11. Table 11 shows that the GKMC algorithm also preserves the category better in this case, compared to the Datafly algorithm. This also means that the GKMC algorithm describes the original data better. The number of attribute categories of the anonymized data resulted when all, only numerical, and only categorical attributes are used, is also compared. The results are shown in Table 12 and Table 13 error. Reference source not found. The tables show that, when the numerical and categorical attributes are processed separately, more attributes category can be preserved, especially when the GKMC algorithm is used for the anonymization process. For example, when all attributes are used, 2 out of 69 categories of age can be preserved. When only numerical attributes are used, 8 out of 69 categories of age can be preserved. The overall results show that when the process is separated, about 55% of the number of attribute categories increases, compared to when all attributes are processed at once. The rest of the number of attribute categories remains the same, they do not decrease. Declustering results. In this experiment, the original data and the anonymized data from both algorithms are clustered, by using K-means clustering algorithm in Weka. The anonymization methods are applied to data with all attributes, only numerical attributes, and only the categorical attributes. The clusters resulted from the anonymized data are then compared to those from the original data, to check the number of matching members between the clusters of the original and anonymized data. The value of K is increased, to observe the impact to the results. These are all done by using another software. The software compared 2 clustering results based on the attributes chosen. The description on how the software works is given in Fig 9. Timeline. Description automatically generated. A close-up of text on a white background. Description automatically generated. Fig 10 shows the results when all attributes are used in the experiment. In general, the matching members of clusters from GKMC algorithm results are higher. It means, the GKMC algorithm gives more similar results with the original data, when the anonymized data is clustered. It means, the GKMC algorithm preserves the data utility better. As the value of K increases, the number of matching members of the Datafly algorithm decreases. For the GKMC algorithm results, the value of K does not give any specific patterns. When only numerical or categorical attributes are used, the same conclusion is also shown, that in general GKMC algorithm gives better results than the Datafly algorithms. See Fig 11 and Fig 12. When only numerical attributes are used, the number of matching cluster members between the 2 algorithms does not significantly different. A screenshot of a cell phone. Description automatically generated. A close-up of a map. Description automatically generated. 6. Conclusions and future works. Based on the experiments conducted, several conclusions can be taken. The first conclusion is, based on the information loss obtained, the Datafly algorithm performs better than the GKMC algorithm. The information loss decreases as the value of K increases, since the Datafly algorithm deletes records that cannot satisfy the K-anonymity requirements. As the second conclusion, the Datafly algorithm has lower execution time because the complexity of the algorithm is lower than those of the GKMC algorithm. The execution time of both algorithms decreases as the number of attributes decreases. In the next experiment, the mode and the number of categories of each attribute are computed. Based on this experiment, the last conclusion is the GKMC algorithm describes the data better than the Datafly algorithm since more attributes of the anonymized data resulted by the algorithm have the same mode as the original data. Furthermore, the GKMC algorithm also preserves more attribute categories, compared to the Datafly algorithm. The computation results also show that, when the anonymization process between the numerical and categorical attributes are separated, the number of attribute categories increases. Since the results indicate that GKMC algorithm preserved more original data information than the Datafly algorithm, as the future works, a different information loss formula should be used, to investigate whether the information loss results can match the statistical properties. The last experiment is related to the number of matching cluster members between the anonymized and the original data. Based on this experiment, the third conclusion can be drawn, namely, the GKMC algorithm performs better than the Datafly algorithm since in general the number of matching cluster members between the original and anonymized data is higher for all cases. This shows that the GKMC algorithm can describe the data better within a cluster. However, there is no pattern found how the value of K impacts the results. The future work is to investigate within cluster statistical properties and compare the results with the original data. This way, it can be found out whether the clusters obtained from the anonymized data are similar to those of the original data. The last future work is to perform classification on the original and anonymized data and compare the results. The classification accuracy will also be computed to investigate how good the classification is.